Hi, this is my closed-loop encoder control implementation on a barren 4-wheel skid-steer robot for 4 feet measured with tape to match the encoder counts. The robot is commanded to move forward. The encoder feedback is used to maintain equal wheel motion and verify the calculated encoder counts. The robot is commanded to move reverse. The encoder feedback is used to maintain equal wheel motion and verify the calculated encoder counts. For pivot motion, each wheel follows a circular arc about the robot center. Using the measured robot dimensions, the effective radius was calculated, and for a 180-degree rotation, the expected encoder count is approximately 16. However, in practice, the robot did not achieve a full 180-degree rotation using this theoretical value due to wheel slip and skid-steer friction effects. To compensate for this, a multiplication factor, or slip factor, was introduced to adjust the required encoder counts based on experimental observations. Additionally, when moving from wood to tile surfaces, reduced friction caused the robot to rotate more, requiring different calibration. It was also observed that left and right pivots behave differently due to motor asymmetry and diagonal encoder placement. Overall, accurate motion was achieved by tuning the multiplication factor. For future use cases, we will be using IMU.